talk about how artificial intelligence and machine learning are transforming some of our key markets, I have with me today Dr. Sriraam Natarajan, professor of computer science at the University of Texas at Dallas. He is the director of both the Center for Machine Learning and the Starling Lab at UTD. Ram, thanks for being on the Tech Between Us.
Thank you. Thank you for the invitation.
In many industrial facilities, maintenance can represent upwards of 5% of the original equipment cost on an annual basis. So anything that can be done to reduce that number, while at the same time helping to be more efficient, is welcome. The Industrial Internet of Things, with its network of connected sensors, brought us condition-based maintenance that started us down this path through the continuous monitoring of vital operational statistics. Predictive maintenance as the dimension of machine learning to more accurately predict when a piece of equipment will fail. So Ram, how does a predictive maintenance system use machine learning along with the petabytes of data that's being collected from these IIoT sensors?
Yeah, thank you. That's a very interesting and definitely a pertinent question. So the developments in the field of AI and Internet of Things are unprecedented, and we are in now what they call the fourth industrial revolution. Of course, the manufacturing processes have become quite complex, with some complex robotic machinery embedded with state-of-the-art software and definitely surrounded by high-tech IoT devices. For the uninitiated, predictive maintenance aims to reduce the industry maintenance costs and ensure operations in a sustainable manner. The goal is to minimize the next error that could happen in the process before the failure actually takes place. So hence the name predictive maintenance. And clearly a problem that has several challenges for any artificial intelligence or a machine learning system. AI, when I say AI from now on, it's artificial intelligence. ML is for machine learning. So for instance, the IoT sensors give us raw sensor data, and to convert that to a meaningful form for the learning system is actually a very big challenge. Sparsity in the data, because faults occur rarely, the data augmentation, tagging, creation, what we call as curse of dimensionality, because the data comes from, as you rightly pointed out, several sensors, in some cases hundreds and thousands of sensors. And of course, there is what we call as class imbalance, which is again related to sparsity. So these are real challenges for any machine learning or AI system. Here, I would like to pause for a moment and clear something up. It's one of my pet peeves that I like to clear in any interview. There is a false equivalency introduced by many people, and media is definitely one such culprit, where it's claimed that AI equals deep learning. I just want to clarify here that deep learning is a subfield of machine learning, which in turn is a subfield of artificial intelligence. AI is much, much more than deep learning. With that caveat, returning to the question of predictive maintenance, different directions have been considered and proposed by researchers in the past few decades, actually, all the way from classic supervised classification, anomaly detection, regression, reinforcement learning, and of course, as always, pattern recognition or clustering unsupervised learning. The key challenge and the key solutions have been proposed in the context of high-dimensional data. Most of these systems follow a kind of a similar architecture. The raw data from sensors, assembly lines, no matter where they are first converted into some form of a real-time streaming database, from which they are pre-processed and appropriate machine learning algorithms are employed. This pre-processing is actually extremely crucial. We introduce what is called as an inductive bias, or additional domain-specific inputs in the form of background knowledge, sometimes called as initial hypothesis, search bias, and so on, are being provided. This is crucial, okay? For instance, I refer to the book, The Bible of Machine Learning, by Tom Mischel. If you look at chapter 1, I believe it's section 1.3, it says on the futility of bias-free learning. Because random multiple hypotheses can easily fit the data. So moving away from predictive maintenance to a simpler example, I want to predict which student passes a qualifier exam. So let's say we put cameras in the entire room and we are observing how the students are working. It is quite possible that the learned hypothesis could say that anybody who's wearing a blue shirt would pass the qualifier exam. Oh, by that logic, I would fail, by the way. This fits the data perfectly because in my current training set, every student who passed might have worn a blue shirt. But you need domain knowledge to tease out things that are not relevant. Okay, so in some sense, this inductive knowledge is extremely crucial. Once the inductive knowledge is provided, the model is built after carefully selecting the features. Then somehow the features are scored, then most of these methods would train a classifier. The classifier is typically a supervised learning if you have fully labeled data. Unsupervised learning if you don't have any labels on the data. So you don't know which are false and which are not, and you just want the model to learn it. Or in some cases, it's called semi-supervised data, where some of the false are labeled, the others are not, and the classifier has to use the labeled data to make use of the unlabeled data. So this is how they do it, and typically this involves many other steps, what people call as hyperparameter tuning, which is really the engineering of machine learning, where most data science jobs are. Like if you get a deep learning system, you got to figure out how to make it work. And that's called hyperparameter tuning, because you have to tune the parameters of the network. While these are all fine and good, the biggest challenge comes is how do you evaluate these algorithms, these models for their generalizability. For instance, how will the model scale to different factories? How about factories in different locations? For that case, even different countries. How about different sensors? Because sensors keep evolving. Basically, with respect to like Moore's law, we get new sensors every other year. How will the systems generalize to that? Understanding the generalization and usefulness of these algorithms is probably the most interesting direction in this space for me. Nonetheless, I think the prospects of machine learning in this space is quite exciting, and the impact can be significantly high. I think I can already see various adaptations of these techniques in this space, and I'm really, really excited to see more in this direction.
That's actually really interesting. From my standpoint, as a pure engineering exercise, we can, like you were saying, gather the data, develop, use the data in the algorithms. But I found what you mentioned on generalization really interesting, because that's an aspect that's, from an engineering standpoint, to me is more of a production type of thing. But it really is a huge issue, because just because it works in the lab doesn't mean it works on every factory floor.
That's exactly right. And just because even if it works on one factory floor, there is no guarantee that it will work in another factory floor. And we want to be able to guarantee that. And I think this is true. And as we go through the podcast, I'll probably refer to this in many other scenarios. It's actually not just restricted to predictive maintenance. It's true pretty much every domain that we consider.
Yeah, once again, because I thought, once again, just coming from a non-AI developer, I figured, okay, we do it once and we're done. And that's not quite true.
No. We have to keep refining the model, because the data changes, the inputs change, the features change. So think about it like this, right? 10 years back when we did all these, online stuff, they were all mainly audio. Now it's all video, right? And so we have new sensors that are coming in, which means that you are going to get new sets of features that your algorithm has to be somehow trained on. But again, we cannot go back and retrain the model every time, because that is wasteful. Then you're going to spend a lot of energy on training and you're not going to deploy it. So we want to be having efficient methods that can, what we call as refine the model, just make small changes to the model so as to accommodate the new changes in the problem space. Could be from the sensors, could be just new data, new machinery, or, for that case, just new production lines.
Wow. I mean, yeah, to me, that's fascinating. The fact that, it doesn't work just because you have a model, it doesn't work everywhere.
Right. And it's almost guaranteed to not work everywhere, because you're looking at a small subset, right? It's kind of like a frog in the well kind of a thing there. You got to be able to see the big picture to make it work everywhere.
Another area that, has seen, tremendous benefit from AI is the area of healthcare. From radiology tools, I know it's helping oncologists look at, different scans of the human body for cancer and things like that, to helping even, trying to, tame medical records. It's pretty much ingrained in the medical industry. And I know a lot of the research, Ram, that you've done at the Starling Lab is in the area of healthcare. Can you talk a little bit about your work in the Starling Lab, and what are some ways that you're seeing that AI and or machine learning is really trying to keep us healthy?
Yeah, thank you. I think this is, thank you for noticing that we work a lot in healthcare. So the way I think about the research in our lab is that we get inspired by problems in healthcare, and and develop fundamental learning algorithms to address these problems. Because I'm a computer science professor, we also want to make algorithmic contributions from looking at healthcare data. The interesting thing is when I finished my PhD, my thesis probably did not have a single word called healthcare in that. But when I was doing my postdoc in Madison, that's when my mentors were introducing me to look at medical data. And this caused me to the interesting side is that I became a faculty first in a medical school for looking at machine learning as a solution for many healthcare problems. And that's when I actually made my move after being in a medical school. So returning to our lab, yes, we focus a lot on healthcare. So first, initially, we looked at electronic health record data and clinical study data for different types of prediction tasks. So for example, we looked at the data of people in their 20s to see if we can predict cardiovascular events in their 50s. So just looking at data between the ages of, say, 20 and 40, can I predict what's going to happen to you in your 50s and maybe even in your 60s? One of the most interesting rules that we learned, well, let me tell you just one very interesting, two interesting rules that are contrasting. The first one says that if the person is a male, and this person is in their 50s, but still lives with parents, smokes regularly, and has children to support, then this person, he is 9 times more likely to develop a serious event than a female who is married. I want to say happily married, but the data doesn't quite tell me that. So I want to say who's at least married for 10 years, has a stable job, and does not smoke. So this is very insightful. You can understand, this is, as you can see, this has got nothing to do with your glucose level or your cholesterol level or your blood measurements or anything of that sort. This is just looking at the stress level of the person. And I can say that this person is 9 times more likely to have a cardiovascular event, right? And another interesting that I saw was, at least in that population that I looked at, people do not change their behaviors in their 30s and 40s. So another way of saying this is basically once a slob, you're always a slob. So the point is that we were able to tease out these interesting rules. And I'm hoping that some of these will be allowing people to modify their behavior, kind of like outside the clinic, not necessarily through medicine, but just through behavioral practices and stuff like that. We also look at predicting onset of Alzheimer's, Parkinson's, postpartum depression, adverse reactions to certain drugs, identifying rare diseases, support groups for rare diseases, and so on. I just want to give you one more quick example on the type of things that we can learn. If you remember, back in 90s, we had these COX-2 inhibitors, Vioxx and Bextra. You probably remember them. People definitely in their 40s and 50s would remember them because they were the second most sold drugs after Tylenol. What happened was in early 2000, they kicked off a clinical study to ascertain the safety of these drugs. Around 2006, they were withdrawn. We looked at the data in one hospital in Wisconsin between the years of 1999 and I think 2003 or 4, I forget, and identified that myocardial infarction or heart attack was one of the side effects. And by the way, this is why they pulled the drug out of the market. And when we looked at it even closely, the even higher risk was elevated blood sugar. It is not clear if the elevated blood sugar actually caused the heart attack. But I mean, that's a problem for another clinical study. But the key point that I want to make here is, if we had access to the data in the years 2000 to 2003, we could have prevented many, many heart attacks between the years 2004 and 6, when people were actually using these on the market. So what we are really trying to do is see if we can do such high impact clinical problems, not just me, the whole community as such. So we have been looking at data, for instance, even outside the clinic, and that's something that I want to emphasize. Wearables and such provide valuable data for us. So I work with a company on using machine learning to detect falls and interactions of dementia patients to see if we can improve their living. We work with Regent Street Hospital in Northeastern on a National Institute of Health, NIH-funded project on predicting adverse pregnancy outcomes, things like gestational diabetes, preterm birth, or other complications with pregnancy. Now we work with Children's Hospital here and UT Southwestern on predicting the efficacy of ECMO treatment in pediatric kids, in NICUs and other areas. More recently, I've acquired the Texas systems COVID data, I'm hoping to identify a subgroup of population that are at the highest risk levels for COVID-related complications. So these are some examples. I'm pretty sure I've left many out of the types of problems we look at. There's a lot of people working on other problems. I mentioned clinical studies, electronic health record. As you mentioned, images, radiology reports, natural language processing. There's a lot of work on genetics, identifying the gene association between disease and treatments. So there's a lot of work on this. And I believe that with more and protein folding for drug discovery, drug interactions, there's a lot of work out there. And there are many journals and conferences that are supporting this work. So I'm quite excited by the prospect of machine learning and AI in healthcare.
As you were going through your list, I was like, oh my gosh, okay, there are just, between diagnostics and imaging and, your AI is really touching just nearly every aspect of healthcare, which will eventually touch every aspect of our lives, from birth all the way till the end.
Yes, absolutely. And, the most exciting thing for us is that the physicians, the doctors are so excited by this. So they are ready to work with us. If you are a machine learning professor, there are at least 5 or 6 physicians who will approach you and say, hey, can we work on this? So there's a lot of interest in the medical community towards adapting these data-driven techniques for, as you rightly said, for diagnosis, for treatment, for even post-care and so on. So I think there's a lot of promise here.
And you mentioned this a little bit earlier when we were talking about predictive maintenance. To me, healthcare is an area where bias in the data can either can accidentally be part of the data set that you use to in your machine learning algorithms. Is that a concern? When you collect data, from these different studies and surveys and interactions that you have with patients and doctors?
Absolutely. I think that's actually one of the most important concerns. And to me, this is also one of the most important issues in the adaptation of AI in the general society, right? So a simple bias could say something like, don't give student loans for somebody who is 22-year-old, right? Sorry, or mortgage loan for somebody who is 22-year-old. But we really have to invest in the 22-year-old to build a better future. If this 22-year-old has a college degree and has got a job offer, why not give a loan there? Because this person is more likely to take up responsibility and pay the loans off. But returning to your question, right? The point I wanted to make with that the loan thing is that the bias can happen anywhere, right? So I want to come back to the healthcare. This is an important issue, right? For example, a classic manifestation of this is what we call as data bias. There are several clinical studies that are essentially collecting data from older Caucasian populations. If you are generalizing these predictions to other populations, African Americans, Latinos, Asians, these predictions can not only fail spectacularly, but the treatments can also become more adverse. I recently read an article about how one specific subpopulation had a higher instance of invasive treatments when compared to Caucasians. Why? Because the study was performed on the Caucasians, and it is true that for the results that it holds very well for the Caucasian population. But then you move it to another group, say the African American population, the treatments become much more invasive, quite unnecessarily. Again, this is very similar to the predictive maintenance point that you made about factories, right? It's just not one factory, it's not one group. You have to be able to extend the predictions, the treatments to all the groups. And this is what we call as data bias. And another data bias, for instance, could be due to age. In our adverse pregnancy, we came across an interesting rule. The rule said that women with advanced degrees had a higher chances of developing gestational diabetes. So really, if I have to reverse it into a treatment plan, basically you want to get pregnant, don't have an advanced degree. But that's not the truth. That is not even half true, right? Because if you look at the data, zoom into our data carefully, that's when we realized many of the population that we had teenage pregnancies in Indiana. And they are not as well educated. The older population, on the other hand, because we collected the data from a college town, tended to be much more educated. So it was the age that predicted whether this person had the gestational diabetes, whether this women had the gestational diabetes, not the education level. So we have to be very careful in these data bias when we work with it. The other side of the coin is what we call as algorithmic bias. See, simple prediction, right? I'm just predicting, well, nobody will die from COVID. Okay? If I just run this algorithm in the general population, I'm going to get 99% accuracy. Why? Because the risk of fatality is only 1%. And 99% accuracy seems remarkable if you just write it just like that. But that's not telling you anything. It actually misses the point. It misses the critical point of saving the at-risk population. So there is a lot of work that acknowledges and removes such bias and introduce what is called fairness in machine learning. So one example is what you call as metric fairness, says that similar individuals should be treated similarly. And that they should not be discriminated, right? Meritocratic fairness, which is basically saying that some specific examples or a small set of patients are merit-worthy and should be treated slightly differently. Group fairness, which is basically saying this subgroup is at risk and they need protection, right? It could be like mortgage, it could be loans everywhere, all the way from healthcare to this. So what do? We work a lot with the experts, domain experts, physicians, mental health professionals, social workers, and in some cases, the populations themselves to understand the specific biases that occur in the data or potentially induced by our model. First, I believe that acknowledging that there is a problem is the first step in solving it. So we acknowledge it and then address it. So once we identify the specific type of bias, they can be overcome in your data collection or during modeling. And during modeling, they can be introduced as what is called as constraint to the learning algorithm. Typical constraint are performance. You know what? You want high performance, high accuracy, high efficacy, but that's not enough. You want to ensure that bias is taken care of and fairness is taken care of. This has been our recent focus in the last few years, is trying to work with the humans, right? That's where humans are important in AI, with the humans to see if we can ensure fairness in the machine learning models.
So there are really actually very well-known and well-determined areas of bias that can be actually mitigated through either data collection techniques or algorithmic techniques.
Right, absolutely, yes. And that has been the focus of many machine learning researchers. You can see these conferences, they have special tracks on fairness, ethics, and transparency in machine learning.
That's really interesting because I know, once again, at a much higher level, talking about AI, to really be able to trust artificial intelligence and trust the results of machine learning, we've got to be able to eliminate, or to the best of our ability, eliminate bias and eliminate any kind of unfairness
right.
with the subject group.
Exactly. It needs to be done.
Now, in the lab or in your experience, what other areas have you seen where AI is having an impact, or do you think will have a huge impact? For me, finance, supply chain, they come immediately in mind. But I don't know if you'll ever write an algorithm that will predict the next stock market crash. If you do, you'll be a gazillionaire. Or whether you can you'll write an algorithm that will always keep my Amazon stuff in stock. Where do you see what other industries do you see AI really making a tremendous impact?
I think it's already having a tremendous impact in many industries, and you listed some of them already. Transportations and logistics are some that immediately come to mind, right? So for instance, we worked with a company in Bay Area on predicting price in logistics, like what is the cost of moving goods from, Austin to San Diego. And we were able to predict within $100. So we were at most off by $100 of the correct quoted value, right? And the quoted value, just to give you the context, was between $100 and $10,000. So with that large range, we were basically within 1%. So that was pretty interesting for us. Predicting supply and demand, again, that's a very interesting problem. So a simple question could be, what should be the correct price of organic blueberries so that I can sell my organic blueberries on sale, but at the same time, not every customer will buy the organic blueberries, so that my conventional blueberries will then have to be discarded or thrown or wasted, right? So you want to be able to balance both. You want the right price point to do that. And I think that can be done using machine learning. I have similar stories in other fields. Healthcare, we talked about, and many success stories. Finance is an interesting domain, but things are so dynamic, so machine learning algorithms need a little bit of tweak to get them to work. But in my head, at least if I have the last 100 years of data, we should be able to predict at least within a reasonable range when the next big crash is going to happen. Of course, that's only looking at the finance data, but stock market crash happens outside the finance data, and we have to be careful there, right? Transportation, I'm particularly excited about it because if we can predict passenger demand, passenger growth, the congestion in traffic, makes life easy, right? Predicting who's at a high risk for credit default. How can we help them? I think that's machine learning right there. I think it's there everywhere. I saw an ad for AI-driven toothbrush. Can you imagine artificial intelligence inside your toothbrush, right? So heck, we see AI everywhere, right? All the way from, as you rightly said, predicting birth to predicting death to recommendation system, social network, product sales. I recently saw an article where they were predicting fashion styles by looking at, they're inferring fashion styles by understanding your attributes, how you dress, and the attributes of the apparel. So in my opinion, AI is going to be there everywhere in the future. I'm very excited for the next 10 to 15 years of AI.
So it really, truly is going to touch every facet of our lives. I had not heard the fashion thing. That kind of scares me, actually. But if it can predict when cargo shorts are back, let me know.
Right. I mean, that would be awesome, right? Because it knows that I wear boring dresses. And if I can get that prediction all the time, then it's great.
We've seen how, we've talked about, AI affecting, all these traditional businesses. And I actually saw on your website that you'll be chairing a special track on AI for social impact in next year's Association for the Advancement of AI conference. Do you see AI being kind of an agent of good for societal issues?
Absolutely. I think there's a huge role of AI in making society better. Climate and ecosystem are prime examples. If I can predict natural disasters, earthquakes, hurricanes, forest fires, now that's scorching the Pacific Northwest here, landfall intensity of cyclones, global precipitation from, say, satellite images, minimizing energy use of public transport, we can make a big impact, right? We are seeing in Germany, we are seeing in the Pacific Northwest, there is drought here everywhere. If we can predict this early, it will allow us to plan better. So there is a huge opportunity in making society better. Even simple things like that most people don't think about, like ecosystems. Can we predict animal populations, at-risk animals, their migrations, poaching, when they're going to be poached? They can have a huge impact in increasing the biodiversity of our environment. Forest preservation using AI-based methods are, I think, an extremely interesting and important problem. Solar flares prediction can, of course, make us prepare better for many of these things. From there, from climate and ecosystem, you can go all the way to internet, cyber attacks. If you can identify cyber attacks, predict it, then the common man, my 72-year-old dad and my 70-year-old mom would be much more comfortable using phone, paying using phone, if I can tell them that this is not going to be, they're not going to be victims of cyber attacks. Healthcare, we already covered. And there could be more social context, fairness in hiring, populations, ensuring diversity, not just from one aspect, from every single aspect. The loans, I referred to that several times. Developing plans for low resource populations, both from resources as in physical resources to things like languages, communication, right? Developing what appear as simple but high impact problems, things like nutrition and diet. Right, better nutrition plans in schools can reduce obesity, and that can be also done using AI. Educating people about political biases, because we can detect them using AI, can bring people together in this divided society. Better language translation can also bring people together. Then we start trusting each other, right? So one problem that has been recently interesting to me is even looking at-risk populations for substance abuse and how can we help them. And I think there is a good chance for doing that using AI and machine learning. So in my head, I see the potential impact of AI in society as humongous. And I just want to say that there are several researchers, thousands of researchers across the world working on these exciting problems. I'm sure I have left some out inadvertently, but I just wanted to give you a high-level idea of the types of things that we can do here.
So once again, even outside of traditional business, AI is being used. I mean, it's being researched. It's being by you and your peers, and everybody's people are looking outside traditional industrial, traditional healthcare, traditional all the traditional institutions at looking at using artificial intelligence really to help mankind as opposed to making someone more money.
Exactly. Right? It's not just about building better recommendation systems for Amazon and Netflix. That is also important. I'm not taking away from it. I don't want adult content for my 5-year-olds, right? So that needs to be done correctly, as you rightly said. Potential for AI in making society and human life better.
As a researcher in artificial intelligence and machine learning algorithms and techniques, I mean, you're constantly pushing kind of the boundaries of what it can do. Do you think that the future of machine learning and artificial intelligence in general do you think it's more of an evolutionary thing, or do you think there's something still revolutionary out there? And I'm not asking you to put a stake in the ground, but get out the crystal ball and where do you think do we have these huge steps still to take to make AI a real thing?
That's a very interesting question, and one that could potentially get me in trouble. But this is my perspective, just my perspective. I feel like the developments are generally evolutionary. There is a natural explanation on why things happen, right? I mean, it's kind of like, Newton inventing calculus was revolutionary. And we use calculus in everything. So the moment you use calculus or Fourier transform is revolutionary, right? And so, but again, they use other building blocks from the foundational mathematics to do that. So most of the developments are evolutionary. So we started, for instance, in the machine learning with simple neural based systems to more complex systems. Then we had expert systems in 80s, and then data-driven machine learning took over. Now everything is deep, and so we have deep learning everywhere, right? The leaps are giant, but the steps have been, in some sense, evolutionary. You take small steps to get the big giant leap at some point. For instance, computer architectures. Like, again, an example going back to Moore's law, it became true. The computers that we used in 1990s would not even be inside our phones today. And that is the reason why we use deep learning, because the architectures became so good, we were able to take these traditional algorithms, improve upon them, and adapt them to the architecture. Now I'm very excited about quantum computers. They could certainly change the way we think about AI and machine learning. So the point I want to make is that while the algorithmic changes themselves can be evolutionary, the impact can be revolutionary. And I think that is where it's very interesting for somebody like me, because you may make a small change to what your current existing algorithm does, but it could really revolutionize a particular problem, a particular area, a particular societal challenge, and solve it. So I think maybe that's my answer, that the impact is going to be revolutionary, but the steps are, for somebody who follows AI, is still evolutionary.
Is there an end game? Is there a final point for artificial intelligence where, as the media says, if you look at basically any media portrayal of AI, it will be the death of mankind?
Again, really an interesting question. I think there are two questions here. So let me first try to answer the final form, and then the death of mankind next. So the final form is, people talk of AGI, or artificial general intelligence, where the machine achieves true human level understanding and performance, right? While I hear this a lot, currently it's mostly in science fiction, okay? And again, this is my personal opinion. Look, I want to build systems that can surpass the humans in some tasks, because when I'm predicting onset of diseases, I want to be able to do it better than what humans do, right? I want to be able to predict the next pandemic before it happens, the different types of predictive maintenance. And we need to figure out if we can predict that before it happens, and that requires more than human level understanding. Again, effects of climate change, building better societies. I want to do this better than what humans could do. So why? Because I give this example a lot, and in a museum that I gave a talk, I was explaining this. Humans are inherently irrational, and in some cases totally suboptimal, and they don't agree. Even physicians don't agree on treatments. Financial experts don't agree. Political analysts don't agree. Experts don't agree. We know that, right? So what is the point of just looking at a human and saying, I want to achieve human level performance, right? Defining performance from a human perspective, in my head, is probably not sufficient. And the definition of what truly is intelligent depends from problem to problem. It's extremely domain specific. So in my view, I don't see a final form. I think every domain will have its own final form and its own definition of what an optimal or a rational agent would be. Okay, so now moving on to your question about the death of mankind. See, the thing is that the fact is, as with any technology, there is use and there is misuse, right? We can use face recognition to identify criminals, or more importantly, identify victims and help them. But the same technology can be used for profiling. Drones can be used to deliver medicines or vaccines, as they are trying to do in India, for instance, or fire at civilians, as was done in India as well. So yes, the danger to mankind is always there with technology. I like this famous quote by Oppenheimer, who in turn quoted the famous Hindu text Bhagavad Gita, and he said, "I become death, destroyer of the worlds." So it is true. It is true that there are some dangers with AI, but I strongly feel it is our responsibility the community, the AI community, the research community, our responsibility to ensure that the technology is properly adapted. The way I see it, you can save lives. It can reduce workload. How awesome it would be if we have only if we had 3-day weekends every week of our life for the same pay. That would be pretty awesome, right? We can build better societies. And I think we should be striving to make that happen. If we identify the dangers early, and of course acknowledge its existence, as I said earlier, there is always hope for building a better future using AI. So while the media portrayal, which is also fueled by people like Elon Musk, is possible, I think the biggest danger of humans is still from humans, not from AI, as it stands today. So to ensure that it doesn't become dangerous, I'm sure we will all work together. And I'm quite optimistic that AI will be a friend and an ally and not an adversary to mankind. So I don't think AI will be the end of mankind. If there is an end of mankind, it's actually the mankind that will end mankind.
Yep, I definitely tend to agree. And as we've talked about, I mean, AI is helping in so many ways and has the capability of making so many areas better for mankind that, but yeah, it just, I mean, I did ask that facetiously, but yeah, and I really appreciate the answer, because I mean, to me, it's exactly how I feel. It's a tool. As long as the tool is properly used, things will be great.
And it's also the fear of unknown, because we don't understand something, we think it's dangerous. If we think we understand something, even though we don't, we think it's not dangerous, right? I have this example all the time, right? I mean, in US, in 2019, there were 33,000 road fatalities caused by human driving. And in the last 5 years, there's been 37 accidents and 1 fatality in Arizona caused by a self-driving car. And we are still hesitant to accept that technology, again, for good reasons. And so, as an AI researcher, it's my responsibility, and everybody who does AI, our responsibility to build the trust. And to do that, we need to build transparent AI that's more ethical, that is more fair, and then people would adopt it and accept it. And I think that's when the dangers can also be overcome.
To help everybody understand what artificial intelligence is, what machine learning is, as opposed to letting the media kind of define some of these things.
Right. So artificial intelligence is where we are building intelligent systems that can learn and adapt and behave over time. Machine learning is a subfield of AI that focuses on only the learning aspect. It doesn't think about reasoning, it doesn't think about communicating, it doesn't think about explaining and stuff like that. It focuses on learning from data. And so machine learning is a subfield of AI, because one of the things that you want to do inside an artificial intelligent agent is to do this learning, right? You look at a 5-year-old. The 5-year-old has all the way from, they have improved their physical abilities, their cognitive abilities, their reasoning abilities, and their learning abilities. So we need the whole spectrum to build a truly intelligent machine. So AI encompasses all these problems.
And once again, it's that, the education, the transparency, I think, will go a long way in helping people become comfortable with AI concepts and machine learning techniques.
Exactly. And as I keep saying, we fear the unknown. So if we can start explaining AI better, start explaining what we are learning better, start explaining why we act in a particular way better, then we trust the system, right? I mean, think about going to a physician. If your physician talks to you about everything, explains why he or she does what he or she is doing, what they are doing, then you understand why they are doing what they are doing. And then you tend to trust them more than a physician who is too busy and doesn't want to talk to you too much. Then you don't trust them. So that's the idea here. Can we build systems that can be understood so that people would increase their trust in these systems?
Right. Increase the trust, increase comfort level, increase familiarity.
Exactly.
We've been talking with Professor Sriraam Natarajan about the impact of artificial intelligence is having in several areas that affect our daily lives and even areas that affect mankind in general. Ram, thank you so much for being on the Tech Between Us. I've actually learned a lot today from you.
Thank you for having me. It was really a pleasure talking to you. Thank you.
Yep, I've absolutely enjoyed it. Thank you for listening to this episode of The Tech Between Us. In our next episode, we'll take a deep dive into the application of sensors and their crucial role in the Internet of Things. Discover more Empowering Innovation Together content at mauser.com/empowering-innovation.